In this project, I worked on implementing quadratic program inverse dynamics for spot with an arm. My work can be broken down into three parts. The first part is building the model. I downloaded the URDF file from this GitHub repository. It was built for ROS. It used STL file format for collision geometry. It doesn't have inertial information. It doesn't have transmission information. I added the transmission, used Blender to convert STL files to OBJ wavefront format. Drake only uses OBJ wavefront format. Use MeshLab to get the inertial information from the OBJ files. The second part is building the PID controller. It is a necessary subsystem to drive the robot to the desired state and keep it stable at that desired state. Spot is an underactuated system. I needed to produce projection matrix to map the actuated states to the desired states. Here I'm showing how the PID is working good with while the robot is static. Once the robot starts moving, it will lose its balance and cannot keep the robot in a fixed position. So we need to do the quadratic program, and we can write the equation of motion given Q and V in this way, and we can split that equation of motion to a free part, the unactuated part, and to the actuated part. The formulation for the quadratic program is to minimize the error cost subject to the unactuated dynamics, the friction constraints, and the constraint of the balance constraint, that keeping the center of mass inside the forelegs. And this is how it performed. I'll move it a bit faster for the sake of time. You can see it actuates the hip roll to keep the center of mass inside the legs. And I have the real-time recording at the end of this video.